Guys, the time has come to talk about a mole. Now, why wouldn't you want to talk about a mole? Look on your computer screen. Look how precious that face is, right? Well, in chemistry, we work with moles. And I wish that we would work with these types of moles, but we don't. We work with a different type of mole. But wouldn't it be nice to be able to hang out with these things in the lab every day? All right, so we need to talk about a mole, and we need to talk about what it means and how to do calculations with it. And this is the part where people hate chemistry. This is the part where people hate laboratory sciences and the mathematics that goes along with it. So, like I've mentioned in the formula weight videos, a mole I need you to think of as an amount. And I equated this to the term dozen. And I said that dozen means 12. Every single time that you think of dozen, you think of the number 12. In laboratories, every time you think of the word mole, you should think about 6.022 times 10 to the 23rd. Now that's a very large number. That means that this decimal place has to be moved 23 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. And then if I go through and put the commas in where they need to go, this is a lot of money, right? 6.022 times 10 to the 23rd. That's the number that needs to be associated with the word mole every single time that we see it in a lab. Now, 6.022 times 10 to the 23rd, that's a lot of words that you have to say out of your mouth. And because of that, we've shorthanded this number to something called Avogadro's number. A-V-O-G-A-D-R-O. Avogadro's number. So 1 mole equals Avogadro's number of anything. 1 mole of salt is Avogadro's number. 1 mole of water is Avogadro's number. 1 mole of aspirin that you might take for your headache, that's Avogadro's number. It's just like dozen. It is a unit that means quantity. And the quantity here is Avogadro's number of 6.022 times 10 to the 23rd. Now, times 10 to the 23rd what, right? Well, most of the time we are using molecules in a laboratory. All right, so that means 1 mole is equal to that many number of molecules if it's Avogadro's number. But the problem here is that this could change. So a molecule would be something like sodium chloride, right? It's an Na and it's a Cl. It's came together in a happy little marriage. It's hanging out with each other. So that, by definition, is kind of called a molecule. But if we just had the sodium only, straight from the periodic table, then that sodium would be an atom. So 1 mole of sodium would be Avogadro's number in terms of atoms. 1 mole of sodium chloride would be Avogadro's number in terms of molecules. Okay? And then if that sodium carried a positive charge, well, that's not a molecule. It's not really an atom. It's called an ion. An ion is anything with a charge. So 1 mole of the Na plus is Avogadro's number of ions of Na plus, right? So we just make it match. That's really all that I'm trying to say. Avogadro's number matches what you have, whether it's a compound that we call a molecule, whether it's straight from the periodic chart that we call an atom, or whether it's an atom that's a charge, and that's specifically called an ion. Doesn't matter which one you got. It'll work for all of them. It'll work for any of them. Okay? But that's Avogadro's number. This is a number that you got to remember. It's a number that you have to memorize because we need it over and over and over and over. All right. Now, other than amount, what else can I say about mole? Well, mole refers to the molecular mass or formula weight or molecular weight in grams that is equal to 1 mole of the substance. Or in other words, that's equal to 6.022 times 10 to the 23rd. All right? Now, what does this mean? It seems like a garbled up mess. All right, well, let's do the formula weight for water. If we do the formula weight for water, it's 16 plus 1.01 plus 1.01. So that's 18.02 grams per mole. So that means if I take water and I measure out 18.02 grams of it, that is equal to 1 mole of water. Well, if I take 18.02 grams and I weigh it out on a scale, that also means that I have 6.022 times 10 to the 23rd molecules of water in that weigh boat. That's all that it's basically saying. That's it, people. No more than that. It basically gives us a measurable quantity in a laboratory that we can use on a scale that's physical, that we can see, that we can touch, that we can measure. That's all that Avogadro's number is, in a nutshell, right? There's more specifics than that on how they got this number, and we can go through that lecture series, but that's not the purpose of this class. It's just how to use these numbers to make solutions, and we need to be comfortable with mole in order to make solutions in the laboratory. And that's all that it means, right? If I take formula weight, that formula weight is in reference to 1 mole of that substance. Well, that formula weight then also means that it's in reference to Avogadro's number of that substance. That's all that we're trying to get across here. That's it. All right? So one of the very first things that we have to do as far as the calculations are concerned is to be comfortable with this concept of going from moles to grams and grams to moles. Right? Those are what we would call our mole calculations. So I'm going to start like a roadmap over here to the side. And if we have grams, we can go to moles of that substance and vice versa if we know the formula weight of the molecule, right? Because that's what it's basically saying right here. Grams, moles, moles, grams. Those two things are related. And these things are related as long as I know the formula weight of the compound. All right, so let me give you kind of an example of where we're going. Let's say that we have a question and it says, how many grams are in 0.325 moles of water? Okay, so let's say I follow a laboratory procedure and the laboratory tells me to use a certain number of moles of stuff. Well, I can't have a balance that weighs out mole. I have to go through and figure out how many grams this stuff is, okay? So in order to do it, grams is related to mole. Can I go from gram to mole? And the answer is yes, I can, as long as I know the formula weight of the substance. Well, we just calculated the formula weight of water, so we need to use it. So this is the way we do it. We set up dimensional analysis. So I take the number that they give me in the problem, 0.325. So 0.325 moles of water. And I always put that over 1 to set the dimensional analysis up. Then in the next step, mole of water on top, mole of water goes on the bottom, and I need to go to gram of water. Let me clear that out. Gram of water. I can go from gram to mole as long as I know the formula weight. And I do. It's 18.02 grams for every mole of substance. So in this step, there's my gram of water right there. This formula weight says 18.02 grams. So 18.02 grams is going to go there for every 1 mole. For every 1 mole. So I'll bring my calculator up, and the only thing that I have to do to solve this problem is to go in and 0.325, and then we're going to multiply by 18.02. And I get 5.8565. Well, rules of significant figures. It basically means when you start with 3, which is what the problem gives you, you end up with 3. Now, I'm not going to be really concerned with significant figures, but I want you to keep in mind that these things do exist and we do use them. But, you know, the point here is not to have a significant figure lesson. That's for 151 and 152. We just need to kind of write down the answer or the number. Basically, I need to keep 3 digits. So 5.86 is what this would round off to. 5.86 grams. So what that means is that if I go into a lab and I weigh out 5.86 grams of water on a balance, and I look at it, physically look at that amount, I will have 0.325 moles of water in my weigh boat. That's all that it is. That's all that we're doing and nothing more. Okay? So that's how we use the mole number in order to convert one to another. So, in the next video, we're going to pick up with this topic, and we're going to do example after example of going from gram to mole or mole to gram. And that's all that we're going to be doing. So stay tuned. Come back.